Complex numbers and roots, section 5.5. As I said, we're going to talk today about what an imaginary number is. An imaginary unit, okay, an imaginary unit is the unit in the imaginary system, the square root of -1. Now, why is that imaginary? Well, because you cannot have the square root of a negative. Okay, for instance, we all know the square root of 4. The square root of 4 is 2. Okay, or the square root of 4 could also be -2, right? Plus or minus 2. Well, what happens when I get the square root of -4? A lot of people want to say, oh, that's -2. That'd be wrong, because -2 times -2 is actually a positive 4. Okay? Nothing times itself does get a negative solution. That's where the imaginary part comes in of an imaginary solution. So anytime you have a negative inside your radical, essentially, anytime you have a negative inside your radical, that means you're going to get an imaginary part, an imaginary answer, and your solution will have the answer I. Yes, sir?
So then it would technically be an imaginary -2.
Square root of -4?
Yeah.
The square root of -4 would actually be what is 2I. Okay? And we're going to talk about these. We'll simplify those. But really what it is, you're going to simplify the radical just like you've been doing. It's no different simplifying the radical. The only difference is now you associate the letter I with it. You pull out the negative and make it an I. That's really what it is. Again, here's another example, an imaginary number. Okay? The imaginary number is the square root of a negative number, which we see that, square root of a negative number, written in the form BI. We'll talk about that here in a bit, where B is a number and I is the imaginary unit. For example, the square root of -16 is 4I. Why do I get 4I? Square root of 16 is 4. Square root of a negative is I. I get 4I. Okay? That's all it's going to be today. Complex number. I'll show you what this is here in a little bit, but complex number is the real and imaginary number put together. So when you combine two parts of these, you get what is the complex number. And the other examples there, 4 plus 2I, 5 plus 0I, 0 minus 7I, all those are complex numbers. Again, basically a complex number is you have a real and an imaginary part. The real part is what you are used to. You know, the number 5, the number 2, 3, -3, 0.1, 1/2. All those are real numbers. Everything we've done up to this point is a real number. The imaginary part is what associates with the letter I. Okay, and when you think of the letter I, it's very similar like a variable. For instance, it's very similar like 3x. Okay, so if I were to ask you, what's 3x plus 4x? You get, anybody? 3x plus 4x? 7x. So if I do 3i plus 4i, what do you suppose I get? 7i. It's just the same thing as a variable, okay? Yes, sir?
Can you take, 4 plus 2i? Is that a simplified?
Because that's as simplified as it goes, because those are different terms. Because the real part and imaginary part, those are different. It's just like 2 plus 4x. I can't combine those, right? And then the last thing we're going to talk about today is what is a complex conjugate. We'll do a lot more with this in the future. Today, you're just going to do kind of the basics of it. But the complex conjugate is really the opposite. It's the opposite of the imaginary part. Okay? So when you see conjugate, I really want you to think kind of opposite. For instance, here they show you 4 plus 3i. The conjugate is then 4 minus 3i. Okay? So instead of positive, it's a minus. And the same thing's true the other way around. So conjugate just kind of means opposite of that imaginary part. We will do a lot more with that next week. And you'll do a lot more with that if you ever get to college algebra. Okay? There's a lot of conjugates there. But again, conjugate is kind of the opposite. So let's look at kind of what this is here. This spiral, some of you are like, well, what's this whole thing? When we started learning numbers, for instance, back in chapter 1, we talked about these sets of numbers. What was the smallest subset of numbers we learned? Natural numbers. The natural numbers were this smallest set. Okay, I'm going to show you how imaginary numbers fits in here. Natural numbers were that smallest set of numbers. After natural numbers, then we had the whole numbers. And remember, natural were the ones that came natural to us when we were little. 1, 2, 3, 4. That's why they were natural. Whole, we added the number 0. After whole numbers, then we had integers. After integers, we had rational and irrational. Now, rational and irrational numbers make up the set of everything we've known up to today was starts with an R? Real numbers. Okay, so all of that is what makes up the real numbers. Today we're going to add what is the imaginary numbers. Okay, today we're going to make up what is called the imaginary numbers here. Notice they are separate of the reals. It's kind of similar to like rational and irrational. Notice you can't be irrational and rational. They're not subsets. They're different complete sets. Same is true of real and imaginary. It cannot be real and it cannot be it cannot be real and imaginary. It has to be one or the other. All of this together makes up what is called the complex numbers. Okay? All of this together makes up what is called the complex numbers. Complex numbers are when you take both a real and an imaginary number. So this is our set of numbers. And again, if you think about that, all the way back to middle school math, back then you did natural, whole, integers, maybe rational. Then you started adding the irrational numbers. And then we talked more about the real numbers. Now, as we progress through math, you kind of add more and more subsets here to kind of think more about numbers as a whole. So here's what we're going to be doing today. We're going to be finding imaginary numbers. So for instance, we talked about it. An imaginary number is the square root of a negative number. For instance, the square root of negative 25. You break it down, you do the square root just like you would. Okay, there's nothing new with the radical. For instance, what's the square root of 25? 5. The only part I'm adding is because it's negative 29. Now my answer is 5i. That's all it is that we're adding today. Okay, so your square roots are still the same. The only difference now is that when you have the square root of a negative, you're going to associate the letter I with it because it's imaginary.
Can I see the charger? Charger? This.
Okay. Complex. All this is complex. Okay. Here's another example. This was very similar. This one is very similar to the one we actually did on our warm-up. For instance, on the warm-up of number 2, it was the square root of 48. Well, the square root of 48 we figured out was 4 square root of 3. Notice, they have negative square root of negative 48. Well, that comes out to be negative 4i square root of 3. Notice, the only difference is because I have a negative on the inside, I include the letter I on the outside. Yes, sir?
How did you get 4 square root of 3?
How do you get 4 square root of 3? What's the perfect square that goes into 48? 16 and 3.
How much one isn't like 8 and 6?
Because neither 8 nor 6 are perfect squares. Remember perfect squares? Like 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. Perfect squares comes out perfectly. Okay. Notice here on this one, I had a negative in front of the radical. So the negative stayed in front when I had my answer. Okay, some people get confused, like, well, why is all of a sudden a negative here? It's just because they had a negative. If I didn't have the negative here, I wouldn't have a negative here. Okay, but again, we're simplifying it the exact same way. We're just going to pull out the letter I with it. And then conjugate, I have down there at the bottom here, examples of conjugates. Again, I think of opposite. So for example, the conjugate of 5i is negative 5i. Okay, again, you're thinking opposite there. Okay, so let's look at some of these. We're going to go step by step. If you can simplify them just like you would any other radical, you'll be just great.
I can't see that.
Oh, okay. Number 1, I have the square root of negative 72. I need to break it down. What is a perfect square that goes into 72? It is 36 and 2. Does everybody see? They kind of broke it down for me already. Now, a lot of times when I do this, instead of, they write it out as 3 different terms, I like to write it out as negative. I like to associate the I with my perfect square and the negative 2 and the 2. Does that make sense for everybody? I just kind of break it down, associate the negative with my perfect square because I know they're going to be pulled out together. If I pull them out together, I don't have to forget about it.
No, I can't.
Okay. For instance, what is the square root of negative 36? 6i. So my answer here becomes 6i square root of 2. Okay, and again, what are we adding today? Well, we're adding this imaginary part. You could have simplified the square root of 72 already. That's something I know you could have done. Yes, ma'am? When we pull it out, we associate it as an imaginary number, that's pulling the negative out. Okay, great question. So that negative goes away because we make it the letter I then. Good question. Number 2, I need to break down the square root of negative 45. So again, I need to find a perfect square that goes into 45. The perfect square is 9.
And 5.
So really this is the square root of negative 9 and the square root of 5. The square root of negative 9 is 3i. So it's 4 times 3i, square root of 5. Does everybody see why there's a 4 times? That 4 was already out front. So now I have to multiply them. 4 times 3i is 12i, square root of 5. Yes, sir, Jesse. Do you have a question?
What you
Pat?
have to do?
Wait, Pat's got a question now.
Why wouldn't you multiply the 4 with the root of 5?
Because the 5 stayed inside. So it's not coming out. I just multiply by what comes out.
Okay.
Good question. Good question. Jesse? Okay. Number 3, square root of negative 100. This one's a little bit easier. What's the square root of 100? 10. So what's the square root of negative 100? 10i. Nice job, sir. 10i. Let's try number 4. 5, square root of negative 54. I need to break down the square root of 54. I need a perfect square that goes into 54. What did you say? 9 and 6. So square root of 54 is the square root of negative 9. I'm going to associate the negative with the perfect square. Again, that way I know they come out together. If that makes sense for everybody, I kind of group them together because they come out together. And then I have the square root of 6. What's the square root of negative 9? 3i. So 5 times 3i square root of 6 gets me 15i square root of 6. Lane, what do you think about number 5 here? I have 2 square root of negative 64. What's the square root of negative 64, sir?
8i.
So 2 times 8i gets me 16i. You guys are doing awesome. Do you see how it's very similar to simplifying radicals? It's really nothing new as it comes to the radical. The only difference here is you're pulling that negative out, making it the imaginary part. Now, this is the toughest one. Negative square root of negative 98. As I think about it, what is a perfect square that goes in 98? Think about it. Do not blurt it out, please. Think about it. What is a perfect square that goes into 98? Perfect square that goes into 98. Think about it. Who thinks they have the perfect square that goes in 98? It's not 4. Yes, sir? It's not 16. It is 49. 49 times 2 is 98. Okay, 49 times 2 is 68 actually. So this breaks down as square root of negative 49 and the square root of 2. Well, what's the square root of negative 49? 7. I. And notice there's a negative out front, so I associate the negative. So it's negative 7i square root of 2. And that's it right there. How are you feeling about these, Jeff? Good. Let's try 6 more. I'm going to erase and come up with 6 more just for you guys.
6 more?
Just kidding. We did 6 more in all classes. Just kidding. We did all. No. How about the square root of negative 50? 4 square root of negative 8. Ooh, that's a good one. Square root of negative 32. What I have? 3 square root of negative 2. That's a good one right there.
Is that right?
Square root of negative 18. And let's go the square root of negative 81. Okay, take a couple seconds to try those 6. Okay, let's look at these here. Square root of negative 50. What's the square root of negative 50 going to be, Lane? Yes.
45 and
So what's my answer then, sir?
5i square root of
5i square root of 2.
5. Oh.
25 times 2 is 50.
Oh,
Can you get 10 and 5?
10 and 5, neither one of those are perfect squares.
I thought 10 were all.
What about number 2, Pat? What do you say about number 2?
Yeah, I did go. Here it is.
Or the second one, I guess.
8i root 2.
8i root 2. Nice job, sir. The third one that is up there. What do you say about that third one up there, Jack?
Dang, I only 4. 4i squared root
It is 4i square root 2. What goes into 32, Jack?
2. 4 and 8. Oh, 16
16 and 2. Number 4, 3 square root of negative 2 is what, Autumn?
3i squared 2.
It's 3i square root 2. The only thing you can pull out of that problem is just the imaginary part. You can't pull out anything else. Just the imaginary part comes out, so that's your answer. What about the fifth one? What do you say about the fifth one? Schultz, what do you say about that one? What's the perfect square that goes in 18? So square root of negative 9, square root of 2. What's square root of negative 9? 3. So I get 3i square root of 2.
What did I do wrong?
And number 6, Tech, what do you say? What? 9i is correct. Nice job. Good work. You guys are doing pretty well. Neither one of those are perfect squares. Next thing we're going to talk about here is the conjugates. What word did I tell you to think about when you saw conjugate? Think of opposite. So if it says negative 9i, what's the opposite there, Pat? Positive 9i. So conjugate is the opposite of the imaginary part. So number 8 here, I have 1 plus 4i. If I think opposite of the imaginary part, I get 1 minus 4i. Those are conjugates. Okay, conjugates, just kind of thinking opposites there. So number 9, 12 minus I, the conjugate would be what, Izzy? 12 plus I. Awesome. Okay, so those are conjugates. Now we're going to advance ourselves onto solving quadratics here. Now here's the thing about these problems. Okay, here's the thing about these. If I were to ask you to solve for x on these, you would do this the exact same way. Okay, the only difference today is instead of having like x squared equals 64, it's x squared equals negative 64. So when I take my square root, what's that telling me about my answer? My answer has to be an I. So I get x equals plus or minus 8i. As opposed to, and when you do this problem other times, you get x squared equals 64. Well, that was x equals plus or minus 8. So the only difference is we're going to have a negative and a radical. It's the only difference about these. Okay. Same is true on this second set. If I go to this second set right here, 5x squared plus 80. If I told you to solve for x, what would you do? Well, we subtract 80, divide by 5. I get x squared equals negative 16. Whenever you have an x squared, you always want to undo by solving. So what's the opposite of a squared term? It is a square root, which is what they do on that next step. Okay? And that's why we take the square root. So the square root of negative 16 is 4i. Now, can anybody tell me why we added the plus or minus here? Why is there plus or minus on all these? Because it's either or. It's both. Very good. For instance, on this top one, 8 times 8 is 64, but negative 8 times negative 8 is also 64. So notice that when we are solving equations here, we need to include both answers, the positive and the negatives. So let's look at number 10 here. I have x squared plus 18 equals 0. Notice, what was the first thing they did on this problem? Kelly, what was the first thing they did? Yeah, they subtracted 18 to the other side. So subtracting 18 gets us x squared equals negative 18. Now, what undoes a squared term, Jeff? What's the opposite of a squared? A square what? Square root. So what do we do here? We take the square root of both. So we take the square root of both. That gets me x equals. The square root of 18 breaks down to the square root of negative 9 and the square root of 2. What's the square root of negative 9 then, Tiana? So I get x equals plus or minus 3i square root of 2. Which is the same thing we were just doing in the earlier problems. Now we're just associating it with solving equations. Okay. Number 11. 6x squared plus 24 equals 0. What's the first thing they did on that problem? Shanka, what's the first thing they did? They subtracted 24. So I get 6x squared equals negative 24. What's the next thing I would want to do there, Jesse? Before I do that, I would want to divide by 6. Getting me x squared equals negative 24 divided by 6 is negative 4. Now, what would I want to do here, Marisol? Take the square root. Nice job. And that gets me x equals. The square root of negative 4 would be what, Nolan? What's the square root of negative 4?
2i.
And now, because I'm doing both solutions, I need plus or minus 2i. Nice job, sir.
You gave that one a mistake.
What about number 12 here? I have x squared plus 49. Mr. Griff, what do you suppose I'm going to do first here?
Probably subtract that 49 there.
I would agree with you, sir. Which would give me x squared equals negative 49. What would I need to do next, Miss Tech? Square root. Giving me x equals square root of negative 49 is going to be what, Tiana?
So she said 7.
Oh, 7i. Nice job. Good work. Try these 3. Take a couple seconds to try these 3. Very similar. Number 13. What do you say about number 13, Mr. Whithelm? Good work, sir. What about number 14? Sequoia, do you have that one?
Yeah.
Nice job.
Congratulations.
And the last one, number 15. Let's go to Lane.
Give me a sec. We got x equals plus or minus 3 square root of 2.
Put out the wrong
It's
part.
backwards, isn't it? 2 root 3.
But you forgot something. It's actually 2i.
To you? You were 15. No, 2i.
Yeah, 15, what would you want to do? You'd want to subtract 12 first. Giving me x squared equals negative 12. Shh, stop, please. And then I would take the square root, sir. So now, square root of negative 12 breaks down as square root of negative 4 and square root of 3. Square root of negative 4 is 2i square root of 3. Does that make sense, sir?
Yeah.
Good work. Here's your assignment.